Hello, here is a video showing how to do a couple of these questions on molar mass and moles. So we're going to do one just out of each section. Let's say that we do the first one, calcium chloride. The first thing I need to do is I need to make sure I have the correct formula. So I need calcium is 2 plus, chlorine is 1 negative, and therefore if I do the teeter-totter or crisscross, my formula is CaCl2. When I'm finding the molar mass, I have to find the molar mass of each of the elements in the compound and add it together. So I have 1 calcium at 40.08, and I have 2 chlorines, so 2 times 3, 5.45. These are all in grams per mole. And so 35.45 times 2 is 70.9, plus the 40.08. My answer here is 110.98. grams per mole. And always when it comes to molar mass, we'll always have 2 decimals after the 2 numbers or 2 digits after the decimals. Okay, so it always has 2 decimal. So, if I go into another one like calcium nitrate, where I do my formula and it's calcium nitrate, and when I do everything, what I end up with when I add it all together, I end up with, in my calculator, it says 164.1. Then what you need to do is add the 0 on there because everything has to be always to 2 decimal places. Okay. The next question here, we have to find the number of moles. So for these ones, we're going to be using the formula that we had in the sheets. So we have number of moles is mass over molar mass. And we have the mass, which is 25.0 grams. We need the formula for methanol, which we can find in our data booklet. It is CH3OH. So I'm going to add 12.01 and then 4.04 for my hydrogens, because I have 4 hydrogens at 1.01 each, and then 16 for oxygen. So the total for the molar mass here is going to be 32.05 grams per mole, and I get 0.78, but I need it to be to 3 significant digits, so I have to add a 0 afterwards, and my units here are moles. So 3 significant digits. Remember that the trailing zeros count, but the leading zeros don't. Okay, this is a trailing 0 right here, and this is a leading 0 right there. So leading zeros don't count as significant digits, but trailing ones do. Now to find the mass, so here again, let's say I'm doing the first one and I need ammonium phosphate. So I need ammonium phosphate. Okay, so again, teeter-totter here. Ammonium is plus, phosphate is PO4 3 negative. So I'm gonna need 3 of these guys to even things out. So I put a bracket and I put a 3 around. And so now here the formula, when I look at the formula for this, I'm finding the mass. So it's number of moles times molar mass. I have 1.22 moles. The molar mass for ammonium phosphate, I'm gonna need 3 nitrogens, 12 hydrogens, 1 phosphorus, and then 4 oxygens. So the total for that is going to be 146.09 grams per mole. And here I want you to notice that moles at the top, moles at the bottom, so those ones will cancel, and then my units will be in grams, so 178 grams for this one. And then the other one I wanted to show you was this one right here, D, because it has only 2 significant digits that we're dealing with. So we have, again, iron 3 nitrite, so I need iron. Nitrite is NO2. I need 3 of those. So I'm going to do again the formula is mass is number of moles times molar mass. So 1.3 times the molar mass of iron. I have 1 iron, 3 nitrogens, and then 3 times 2, I have 6 oxygens that I have to add up together. So here the answer I'm going to get is 252 grams. But Here I have 2 significant digits. Here I have 3. I can't have 3 significant digits. So what I can do is I can divide it by 1,000 and get my answer in kilograms. So here I would get 0.25 kilograms. Or what I can do is I can have it in scientific notation, where I write down the first 2 digits, 2.5, and then I count how many times that I have to move my decimal. My decimal is over here, so I had to move it 2 times for this position. And so it'll be 2.5 times 10 to the 2 grams.